Okay, geotrig, this is lesson 10, day 3. This is the next subject. The next subject now is actually completing the square. We got to complete the square now to solve equations. Even to graph equations, we could complete the square to change forms. What you guys see up here is parts of a quadratic. I've got the first one being an x squared plus 28. Actually, sorry, I need to add something. That should be 28x. Put that x in there. Plus something. The second one is m squared minus 1/8 m plus something. The job here, guys, is to complete the square so that I can rewrite it as a perfect square. Now, wait a minute. Let's back up. What is perfect square? If I was talking about numbers, a perfect square would be something like 4, 9, 16, 25, 36, 49, 64, 81, right? 100, 121, right? You guys know those, right? Actually, you should possibly try to remember your perfect squares. I think at least up to 400, maybe even higher. Not as in 400 squared, but 20 squared is 400, right? Because if you guys start to notice, we learn math with very contrived problems. The real life math is not nice. It's very messy. Very, very messy. So what we do is we take certain problems with nice numbers and give them to you and say, if you can apply this, you should be able to apply it with the messy numbers. And so a lot of the times, those perfect squares come back to us and are very helpful. So, but I'm right now not talking about an individual number. I'm talking about a perfect square binomial. What I mean is this. X plus, right, I'm not going to use x's. I'll use something else. A plus b squared. That or a minus b squared. Those are perfect square binomials. We've dealt with this before. I could expand these. Now, be careful. Don't make a rookie mistake. This is not a squared plus b squared. Or a squared minus b squared. You need to, if you have to, separate them, because you got two of them, and then use the four-letter F word. FOIL. Or, do you guys remember the patterns? A squared
plus AB
plus more than AB, it's
what?
2AB
Oh yeah.
plus B squared.
Well, I did AB.
Okay.
Yeah.
And then if I was talking about the second one with A minus B squared, it's still A squared, but now it's minus 2AB plus B squared. Those are my expansions. Guys, what I'm trying to do is I'm trying to create this here over here. And if I can create that, then I know I can write it as A plus B or A minus B. That's completing the square. Now I'm assuming most of us, if not all of us, have completed the square in Algebra 2. It should have been one of those lessons that is kind of the next step in solving. You could factor things, you could use a quadratic formula, you can use completing the square, or you could graph it. Completing the square with ax squared plus bx plus c actually makes the quadratic formula. And so maybe you've seen that already as well. But what this means is that I am going to be given these problems here. I need to find the c value, or in this case, b squared, so that I can write it as a plus b. I'm going to show you that this is really, really simple. Step number 1. Step number 1. Find half of b. It's in standard form. You should always put it in standard form, really. Maybe that should be step 1. But once you have things in standard form, it says take or find 1/2 of b. What's b in our first problem? It's 28. So what's half of b? What's half of 28? It's 14. Okay. 2. Square the 1/2 of b. That's kind of it. So if you guys told me it would be 14, and I say 14 squared then, right? Half of b is 14. Step 2 says square that number. You would see 14 squared. Now granted, some of us will take our calculators out, some of us won't. What is 14 squared? 196. So technically, this polynomial, if I complete the square, 14 squared is 196. Is everybody okay with that?
Yeah.
I just completed the square. That is a perfect square trinomial. That fits this pattern. Now you might not see it that way. Well, here's the thing. X is like A. X is in both of those, isn't it? But 28, wait a minute, there should be a 2 in front. So that means A, or B itself, should be a 14. And then it should be 14 squared, which is 96. It's there. The next part says rewrite it as a perfect square trinomial. I need to write it like this. Under normal circumstances, if I see this and I say factor it, you guys would be like, okay. X, what are the factors of 96 that give me 28? 14 and?
2.
14.
No, 14.
Plus and plus, yes? So I completed the square. Now I'm just going to factor it. But wait, what's x plus 14 times x plus 14? X plus 14 squared. So I found the two values that I'm looking for. I'm finding the value that completes it. It's 196. And I wrote it as a perfect square trinomial. Or perfect square binomial, sorry. No, wait. Is there happen to be a connection from the way I wrote it this way to the answer down here? What's the connection? I left this as 14 squared for a reason, because what goes with the x? 14. Yes. So, step 3, I'm going to add to step 3, I'm going to say rewrite as perfect square, right? That was our last step in the parentheses. So that means all I have to do is make sure it's in standard form, take half of b, square it, leave it as squared first, so that that answer that you have in parentheses follows into the parentheses of this perfect square binomial. Okay, let's put this to practice. Look at the next one. M squared minus 1/8 m. What's b? It's a negative 1/8. What's half of negative 1/8? It's a negative 1/16. Some of us might not understand that. We're not visualizing that. So wait a minute. Instead of saying take half of something, what do you mean when I say take half of something? It's like dividing it by 2, right? But if I say take a half, it's multiplying it by a half. So would it be okay if I literally just multiplied it by 1/2? And how do you multiply fractions?
Top times top, bottom times bottom.
Yes. Which ends up being negative 1/16. Guess what goes in this box? Negative 1/16 squared. That was step 1 and 2. Now, we could find out the exact value of that because we could square a fraction. When you square a fraction, you square the top and bottom. You square -1, it's square 16, 2,
220
50,
Yeah.
6,
56, yeah.
256.
Yeah.
This is the value of c that completes the square. That's what -1/16 squared is. What does it look like when I put it into here, though? What is it? Ready as a perfect squared binomial.
Don't we want to use M first?
Don't you take half of 256?
I'm not going to take half of 256. I took half of b. It's x.
It's x plus 16.
It's not x plus 6.
Minus.
It's a minus 1/16.
Why is it X now?
Oh, sorry. Yeah.
I just want to make sure that...
Nope, you're right. Sorry. We're in m, so it's m. Sorry. Yes, it's m minus 1/16. So it takes the sign of whatever half of b is. See how much easier it is just to
It's actually really...
put that right in there? Guys, that's probably the most difficult part of completing the square is recognizing that. If you can recognize and you're okay with that, the next step is to solve by completing the square. And if that's the case, notice what I'm doing here. I'm adding 196 to this side. Can everybody see that? I'm adding 196 here. If I add 196 to a side of an equation, what else do I need to do? Add it to the other side. So right now we don't have an equation. I'm just completing the square. Eventually it's going to equal something. So therefore, what you do to one side, you have to do to the other side. So be careful on the next slide. I would write this down. Notice that step 3 is basically completing the square, which we just did in like 2 steps, 3 steps. This is my steps for completing the square when solving by completing the square. Okay? Step number 1, you need to separate the variables from all else. That means your x's on one side, constant on the other. Or a's or m's or whatever's there. Step number 2 is a twofold type of question. There are 2 types of quadratics. You guys know this. There's the nice ones where a equals 1. A lot of those we like to just factor, if we can. Not always an option. The second option is when a does not equal 1, because that's a lot more work to solve them, right? Same thing here for completing the square. Step number 3, complete the square. Take a half of b and square it, but add it to both sides. Step number 4, factor the one side, aka create the perfect square binomial. On the other side, you will actually square it, square the number, and add it to the other stuff. When you do this, guys, you will have a squared term equaling some numbers. So to get rid of the square, you take the square root. Don't forget, you need a plus or minus, and then you can solve for the variable that is remaining. Those are the 6 steps to solve any quadratic by completing the square. We're going to go into those now. So make sure you have those written down. We have 1 of each type.
Can you go back, please? We're going to finish this today.
There is the first problem, which is a nice completing the square one, because a is equal to 1. You can see that out front, right? And then the second one, a is not equal to 1. Okay? There's a couple options here. Okay? And even the second one, there could be another level to it. And I'm going to show you that it doesn't really matter. We're going to solve them the same way. Okay? So, back to number 1. Number 1 step said what?
Separate variables from all else.
Okay, so your variables are x's. What's not an x with the x's?
30.
30.
Nice.
So I subtract it over. which leaves me with x squared plus 10x equals negative 21. Is everybody okay with this? Mr. Konchak, why did you just leave this huge void before the equal sign?
I did too.
Oh, didn't leave it.
Now, guys, there's a reason.
Wait, I did.
What's step number 2?
Well, step number 2 says make sure A is equal to 1.
Okay, it says make sure A equals 1. Well, we already established A was already 1. Guess what? I'm jumping over step 2, thinking about step 3. What was step 3? Add something to both sides.
So 25.
So guess what? I actually,
No.
I will add something to both sides. I left the intentional space knowing I needed to add something, aka complete the square.
25.
We now have to add that step 3, which is half of b squared. What's b?
Yes.
10. What's half of 10?
5.
Okay, I'm going to change colors, guys, because it's going to become 5 squared.
Not 25.
Now, guys, careful. Again, just like last time, I purposely wrote it as 5 squared or half of b squared because one of the next steps says I need to factor that thing. And 5 happens to be the answer inside that parentheses, remember? Now, when I move to the other side, I actually am going to square it. And 5 squared is 25. Because now I move to step 4, and step 4 says factor the one side and simplify the other. When I go to factor this, I end up with what? X plus 5. You can't make it any more simpler, if that's even a word,
More simple is what you're doing.
than that. And then you just got to put the other side together to get what? 4. Moving to step 5 says start to solve it by taking the...
Square root.
Basically, at this point, you need to solve for x. Square root both sides. When you square root, yes, they will cancel out the squares and the square roots, but you can't forget
Square both sides.
plus or minus because you're solving for a variable. So x plus 5 equals plus or minus, and what's the square root of 4? It turns out nice. Guess what? How many answers are we going to have?
2.
There's going to be 2. I have to get x by itself. That was the last step. Solve for the variable. So to get x plus 5 out of there, you subtract 5. Now, here's the issue. Students are automatically going to go and put the 5 and the 2 together. That's a no-go. Guys, any value you are bringing over at the end needs to go in the front. You cannot directly apply it to the plus or minus value. Because at this step, there are 2 values. One of these is negative 5 plus 2, where the other one is negative 5 minus 2. And what's negative 5 plus 2?
Negative 5 plus
Negative 3. And what is negative 5 minus 2?
negative 7.
Those are the answers to x to solve that equation. Day 2's homework is problem 12 on page 81. Have a great day.